Here we come to the last example on page 15, with Roger serves a tennis game as illustrated in the diagram. He served the ball at 100 km/h at an angle 5 degrees below the horizon. So as we can see, we have 100 km/h, which is not a SI unit. We would not like to mess with the unit, so that's why we are trying to convert the unit, not 180 km/h, but 50 m/s. So we are going to resolve the velocity into its horizontal component, which is 50 cosine 5 degrees, and with a vertical velocity of 50 sine 5 degrees. The ball will follow a projectile motion, and we are going to determine whether the ball can pass the net or not. The dimensions are illustrated here. Roger served the ball 2.5 meters above the ground, and the net is 1 meter high. So in order to let the ball pass the net, the ball must not fall more than the difference. The difference is 1.5 meter. The ball must fall less than 1.5 meter when it goes for 12 meters across. So firstly, we would like to know, let's say the ball is at this position when it is right above or below the net. We assume at the beginning time is 0, and this is time t. First of all, we need to find the time t first. And we can find time t by considering the horizontal motion, because the horizontal speed is known, horizontal distance is also known. So let's consider the horizontal motion, and we use the equations of motion, Sx equals uxt. So let's put in the numbers. Sx is 12 meters, ux is 50 cosine 5 degrees times t. So t is given by 0.2409 seconds. So it takes 0.24 seconds to go from this point to this point. So the other question will be, within this 0.24 seconds, how far did the ball drop? What is the vertical displacement? So this is the second thing we have to find the vertical displacement. So we consider the vertical part of the motion. So we use the equations of motion. Sy equals uyt plus half at squared. We put in the number. Uy is 50 sine 5 degrees. T is 0.2409. And half A is here, let's take downward as positive. So A is 9.81 and time is 0.2409 squared. So by calculating this, Sy is equals to 1.335 meter. So that means within this time period, the ball has fallen for 1.335 meter, which is less than 1.5. Okay, the ball has to fall 1.5 meter before reaching the net, but it has only fall for 1.335 meter. So therefore, the conclusion is the tennis can pass the nets.